Geometry lesson 7.5. Okay, let's see how we did on the warm-up. All right, they're showing me, number 1A, they're showing me that this segment here that's inside my triangle is parallel to this third side that it does not intersect. And what we talked about in 7.4 is what that means is that it splits the other two sides into proportional segments or proportional lengths. All right, so to solve this, a lot of different ways you could set this up. I did 12 to 9. The ratio of that side is proportional to the ratio of the second side. Now, since I went from like this angle to that segment, you got to be consistent. All right. One thing I noticed, I graded your guys' 7.1, 7.2 quizzes. They're just not like entered in the grade book yet, so you'll see them on Monday. But some of us, what I noticed on the quiz, are like trying to simplify proportions, which you can do that as long as you only like simplify one side. So like this, I could simplify to 4/3 if I want to, but you can't simplify like this way. That's only when you're multiplying fractions. Now, obviously, I know 20 and 9 don't have any common factors, but that's when you can simplify before you multiply fractions. In a proportion, you can't do that. And if that's confusing to you, then just go ahead and cross multiply without doing any reducing, and you'll get the right answer every time. So if you wanted to just cross multiply right from here, or I personally just like to reduce the fractions or like the ratios if I can, like so, because then when I cross multiply, it just makes my numbers smaller, but you don't have to do that. All right, so I got x to be 15 for number 1. All right, for number 1B, same idea here. They're showing me this segment is parallel to this side that it's not touching. So it's going to split it up into proportional pieces of each side. So I would do this to 18 is proportional to, all right, since I started that angle, x minus 3 to 15. There's a beautiful proportion. Lots of different ways you could set this up. You could have went 15 to x minus 3. And if you went that way, then you would just have to go 18 to x plus 2. You could have done that as well. As long as you get the same equation as me, when you cross multiply, you're good. All right, so here I have 18 times x minus 3. It's 15 times x plus 2. I ended up getting, dun, 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 don't forget to distribute with ones like this. I got x to be 28. Okay, let's see if you can go 3 for 3. This time, I don't know if these 3 lines are parallel. They said, figure out what y needs to be so that we can conclude J, K, and L, these 3 lines are parallel. Okay, so this is kind of like the other part we talked about in 7.4. And the stuff will be on your quiz on Monday, your 7.3 and 7.4. Is that as long as it splits it up into proportional pieces, like this to this, so I could set up the ratio that way, is proportional to, all right, so I started with 2y minus 10, so I start with 4. The ratio of this other transversal that's intersecting, as long as they're proportional, then we can conclude these 2 lines are parallel. However, this is not 10. What's that distance? 6. Good, so be careful with that. Okay. All right, I did reduce this before. Now, I was just kind of, I just looked at my paper and I set it up a different way on my paper than I just did right now. And again, as long as you're consistent with your ratios, should be good. Let's go this way. All right, what did I get for y here? I got y to be 8. Looking like it's going to work out. Y is 8. Anybody get all 3 of those right? Nice. Okay, that's a review. Today, I'm going to throw it back to some stuff we talked about, some vocab from chapter 5. Oh, yeah. And then apply it to similar triangles and proportions. Okay, first one. Who remembers what an altitude is? Don't look at your notes. Tyson?
Is it a line that is perpendicular to the opposite of an angle that goes through the angle?
Yes. Yep. So it's like from a vertex, from an angle, perpendicular to the opposite side.
Yeah.
Nice. Alejandro, you remember that, right?
Yeah, I just.
How to get those? Dig way back in those file
Yeah.
cabinets up there. Yeah. All right. So in this picture, AD, that's an altitude, and so is FJ. All right, we're gonna write down what an altitude is. You guys don't remember. Altitude from the vertex perpendicular to the opposite side. Okay, so here's what's new for us today. They're telling us as long as these two triangles are similar. So here's what we already know. We know if two triangles are similar that all their corresponding sides, such as like AB to FG, that ratio, is proportional to every single set of corresponding sides. So I could say BC to GH. And I know that's proportional to CA to HF. Okay, we know this, right? As long as the triangles are similar, we know this is true about their corresponding sides. So the new piece of this today says, guess what? As long as two triangles are similar, their altitudes are also going to be proportional to this scale factor. So their ratio, or their ratio of their altitudes, I would say AD. Notice how I'm doing the first triangle up here. AD to FJ. The ratio of those altitudes is going to be proportional to all the corresponding sides. Okay. That's not the only special segment that's also proportional to the scale factor. So are the angle bisectors. Remember what angle bisectors are?
Yeah.
That one we remember?
It's because it's in the name.
Right? It tells you. It splits the angle in half. That's what bisect means, right? So angle bisector is also from a vertex. Splits angle into two congruent angles. That's what an angle bisector is. Here's a little test for you. Do you remember what the point is called where all the angle bisectors intersect? In center. Nice. In center. Okay, that doesn't have anything to do with this. This is just fun. That was a trivia question. All right, so same thing. As long as the triangles are similar, their angle bisectors are going to be proportional to all the corresponding sides as well. Okay, so LP. Well, actually. All right, I'll start with that one, the smaller one. LP to RT, whatever the ratio of their angle bisectors, that length, is going to be proportional to all the corresponding sides. So LM to RS. And you can use any of the sides. And how you decide which side to use depends on what information is given to you. KM to SQ. Whatever the scale factor is, the angle bisector follows suit. Okay, that's fun. There's one more that's also proportional to these. Do you guys remember what a median is?
Right there.
How do you describe it?
Midpoint of connecting from the vortex.
Vortex.
The vertex. Vortex. The vertex of one angle and connecting to the midpoint of the corresponding line.
Good. From the vertex. It's okay. Sometimes it's hard for me to talk to.
English is just frustrating.
I agree. That's why math is better.
Yeah.
All right. From a vertex to the midpoint of the opposite side. Good. See how math just like builds? Like you gotta know chapter 5 to know chapter 7. You gotta know geometry to know all the shit. Just beautiful big picture in the end. Big building blocks. All right, so this is the same thing, that their medians are also going to be proportional to all the corresponding side lengths, okay? So let's write this one. CD, that median to YZ is going to be proportional to, I'll start with this, AB to WX to BC to XY to CA to YW. Okay. So like I said, we already knew this. We already knew this before today, that in similar triangles, all their corresponding sides are proportional. They have that same scale factor. Here's what's new for us. The medians are also proportional to that. So are the angle bisectors. So are the altitudes. That's the new part. Okay, let's try some. All right, in this figure, they're telling me that I have two similar triangles here. Triangle LJK is similar to, remember that's what the symbol means, is similar to triangle SQR. Identify the special segment and find the value of X. All right, so they're talking special segment. So here's my triangles. What special segments are they showing me here? Medians, right? From the vertex to the midpoint. So identify the special segment, medians. I don't know, like medians, middle of the opposite side, if that helps you remember it. All right, so what we know now is that the lengths of these medians are proportional to the lengths of all the sets of corresponding sides. All right, but looking at my picture here, I don't know JK, which corresponds to QR. I don't know either of those lengths. I don't know LK, which corresponds to SR. I don't know either of those. The only ones they're giving me are those opposite sides where it passes through the midpoint. So here's how I'd have to set my proportion. And again, there's different ways you could do this. I like to start at the bigger ones, the longer ones. So I go 12 to 8. The ratio of the medians is proportional to these corresponding sides. Now here's a tricky thing. I'm not going to do X to 5 because that's not the length of the side. They're showing you this distance is 5. And if it's the midpoint, what's this distance? 5, which means this whole side is 10. Okay? Same thing here. I want to call this whole side 2x. I just said the answer. Dang it. This side's x. This side, so the whole side is 2x. All right, now since I started with 12, since I started with triangle LJK, I would have to do 2x up top. And I'd have to do 10 on bottom. All right, now you can cross multiply if you want from here. Again, I prefer to reduce the fractions or the ratios if I can. We can't cross reduce, but we can just reduce each fraction. So I'm like, hey, this reduces to 3/2. This one I could even reduce. Think of this as a fraction. 2/10 is 1/5, so that's the same as x over 5. If you want to do that, you can. If not, no worries. You should all still get the same answer as long as your math correct. All right, you can say 15/2, or if you guys are talking about length, 7.5 is a beautiful number. That's it. Let's try another one. Similar setup here. Get it? Similar. It's a pun. This time ABC is similar to FGH. Identify the special segment. Ooh, okay. Which special segment, it's hard for me to say, special segment are they showing me here? Altitudes, good. Okay, so what we know is that the ratio of altitude to altitude, I'm gonna go 9 to 6, is proportional to any other set of corresponding sides. In this case, they're showing me these two sides, so that's what I would use for my second ratio in my proportion, 21 to x. And again, I started with this triangle, so I gotta use 21 first. Okay. These kind of get like a little tougher algebraically, but for the most part, as long as you understand like this concept, this is all it is. In this case, x is 14. All right, I'm gonna do one more like this, and then we have one other theorem. It's a great Friday lesson. Any questions? Okay, last one, like this. Again, I have a set of similar triangles, ABC to XYZ. Identify the special segments and then find the value of x. All right, which special segments are you showing me this time? Angle bisectors, that's what they're showing me right here. Splits the angle into two congruent pieces. How'd it go, Sid?
Pretty good.
Angle bisectors. Okay, so we know that the ratio of angle bisector to angle bisector, I'm going to go 10 to 8, is proportional to any corresponding sides. Again, they're kind of giving me this one, 24 to x. You too. All right, so again, we can't cross simplify in proportions, but we can simplify the fractions if we want. Just curious, how many of you would like just cross multiply right away? Half of you? More than half? Okay. 5x. You get the same answer, obviously. All right, 96 fifths, as this is an improper fraction, or 19.2 is fine too. Since we're talking about only. Okay, the fun thing about angle bisectors is they have one other kind of special characteristic, and that's our last theorem for today. Now notice how this picture, they're only giving me one triangle. So this isn't like a relationship in similar triangles. It's just a relationship with proportions of an angle bisector in any triangle. It says an angle bisector in a triangle separates this opposite side. Now, just as said, remember that's called an incenter, where all the angle bisectors intersect, and that's the incenter is always located in the triangle. So the angle bisector is always going to intersect like that third side. It's going to split it into two pieces. And these segments are going to be proportional to the other two segments from angle J, the one that it's bisecting, okay? So again, I don't have any like comparison scale factor of the similar triangles. This is just another proportional relationship with angle bisectors in any triangle, okay? So as long as it's an angle bisector, it's going to split, which it is in this case. It's showing me right here. It's going to split this third side. So let's go the ratio of Km to ML. It's going to split that side into a ratio that's proportional to the other two sides. Okay, now I'm going to be specific. I want you to put Kj on top. I'll explain why in a second. To Lj on bottom. These ones can be like a little confusing to set up because you're like, well, does it matter which side I list first? And it does. So if we said Km first, which we did, Km in my first ratio, in my second ratio, I have to pick the side that forms angle K. All right, so you have to pick the sides that form the same angle. And we'll do a couple examples, but. So I notice on bottom how I had ML right here. And then in its ratio and its proportion over here, I pick the side that forms angle L. Okay. All right. We're just going to check 2. And that's it. So again, I'm not given like a set of similar triangles here. So there's no like scale factor or any of that stuff. But they're showing me that I have an angle bisector right here. Angle bisector. So what I know from this theorem is that it's going to split this third side. So let's go, like me, I like to go largest to smallest. It's going to split that side 7 to 5 into a proportional length of the other 2 sides. All right, so since I started with 7, I got to use a side that forms the angle with it. I got to use 21 up top. And then since I put 5 on bottom, and it kind of helps if you trace, I got to put N, the other side that forms that angle. All right, you guys know how to solve proportions. This one's nice and simple, and it's 15. Okay, we're just going to try one more that's a little bit harder because that was too easy. You guys look really bored. You look like you did a challenge. Here we go. Okay, same idea though. I only have one triangle and I see it's an angle bisector. So I know it's going to split this side. Let's go X to, ooh, what do I call this segment? Careful. The whole thing's 20. Yep, it does matter though because we're subtracting. The whole segment's 20 minus whatever that segment is, 20 minus X. Okay. We know it's going to split that third side into a ratio that's proportional to the other 2 sides. Which side do I have to put up top in this case? You can just shout out. 14. Good. The one that shares this angle. 14. On bottom, 11. Good, guys. Cross multiply. All right, and here I get a decimal. You could keep it as an improper fraction if you want, but it's a nice 11.2, so either of those are fine. That's it. That's the day. That's awesome.